Okay, so question number 5. What is NH3? Is it a strong or weak base, a strong or weak nucleophile? Okay, so first let's draw out the Lewis structure for NH3. And to write out the Lewis structure, we need to calculate the total number of valence electrons. So for nitrogen, the nitrogen atom has 5 valence electrons, and in the case of a hydrogen atom, there is 1 valence electron, but we have 3 hydrogen atoms, so we multiply this by 3, and we get a total number of 8 valence electrons. So now I'll draw nitrogen as my central atom, and then 3 single bonded hydrogens. And now at this point, I like to count out how many electrons I've drawn so far. So in the case of these double bonds, each of them houses 2 bonding electrons. So far I've drawn 6, so I only need 2 more. So the last 2 I'll just put as a lone pair on my nitrogen. So now this is the Lewis structure of NH3. So now back to the initial question, is it a strong or weak base, a strong or weak nucleophile? So in the case of NH3, NH3 is actually a weak base. So this means it only partially dissociates into its ions. In solution. Is it a strong or weak nucleophile? So NH3 is actually a nucleophile. And this is due to nitrogen's lone pairs. So these lone pairs, they provide electrons to form covalent bonds with other atoms. So let's see what the junior tutor said. NH3 is a nucleophile because it has a lone pair of electrons and a partially negative charge on the nitrogen atom. A nucleophile is a reactant that provides a pair of electrons to form a new covalent bond, so nucleophiles are Lewis bases. NH3 is a weak base because it only partially ionizes and dissociates in water. NH3 has a stronger nucleophilic character than a water molecule. The oxygen in the water molecule isn't likely to bond with any carbon atom compared to the nitrogen atom because oxygen is more electronegative than nitrogen. It holds onto its lone pair tightly than nitrogen. Okay, so this solution is correct.